Good morning, ma'am. So first off, before we start off the presentation, I'd like to introduce everyone. So we are doing about sentiment analysis model, and I'd like to introduce everyone before we begin. So first off, I'm Demus. I'm doing the research about the sentiment analysis model. Second off, we have
I'm Terence Mokichun.
I'm Fujala.
I'm Tan Chua Ming Yu.
I'm Lo Kuan Yew.
I'm Hugh Jun Lok.
start off by introducing our brief our project. It's about sentiment analysis. So this is a brief overview. So this project focus is to program different sentiment analysis models to classify text into multiple sentiment categories beyond positive, neutral, and negative. Other sentiment analysis mainly works on binary classifications, which our approach is to detect emotions like happy, sad, and excited, or other mixed emotions. So the problem at hand is that sentiment analysis models are limited to basics polarity classification, example, positive, negative, and neutral, which does not capture the complications of human emotions in text. However, in the real world, understanding the scale of emotions is crucial. The goal is to improve sentiment classification by executing a human-like model that detects a wide range of human emotions. So here are some context or background. So the sentiment analysis is now widely used in social media nowadays, like customer feedback, product reviews, and it classified into three categories, like positive, negative, and neutral. So positive, for example, is I love this product. Negative is the product I find is terrible, and neutral, which is I find this product so or not bad. So, but human emotions are more complex than just positive or negative. We have other emotions too, like joy, sadness, excitement. So our aim is to program and understand different sentiment analysis model that can classify text into many other emotions. We are trying to improve the existing sentiment analysis by comparing pre-trained transformers to find the most efficient one of the sentiment. So instead of just positive and negative, our model will classify into multiple emotions. And it will enhance sentiment in social media, like customer review, by analyzing the dataset. We will explore how emotions are carried out, and we aim to expose biases and area for improvements.
I will be presenting the literature review. So for our scope, we will focus on text classifications using naive Bayes classifier, particularly multinomial naive Bayes and complement naive Bayes. The project involved text pre-processing features extractions using back-of-words, classifier performance, and comparing MMB and CNB. Secondly, comparison. For trainings and evaluating, we evaluate naive Bayes classifier using accuracies, classification reports, and confusion metrics. We compare NMB and CNB to determine the best approach for different database. There will be two techniques, that is multinomial naive Bayes and complement naive Bayes. For multinomial naive Bayes, it is best for words frequency-based classifications. For complement naive Bayes, it handles imbalanced data set better with improved recall. Lastly, motivations. Naive Bayes is computationally efficient and well suited for small to medium-sized dataset. Unlike deep learning models or SVM, it offers a lightweight alternative.
Hi, my name is Jalo, and I will present the method in our project. So in this project, we use multiple approaches to accomplish our goals, such as long short-term memory models, word embedding models, multinomial naive Bayes, and complement naive Bayes. So why we use these approaches? The long short-term memory model is well suited for processing long sentences, as its human-like memory allows it to retain and recall passwords effectively. Besides that, the growth and word embedding model is a pre-trained word presentation technique that transforms words into meaningful vectors from. It offers benefits such as reducing training time, encoding semantic relationship, and effectively handling synonyms. Growth embedding help LSTM understand word relationship between better and improving sentiment classification. Together, growth and LSTM combine their strengths, making them the best of both worlds. Why we use multinomial naive Bayes NMB and complement naive Bayes CNB for text classification. These models are widely used in natural language processing because of their efficiency and effectiveness in handling text data. NMB works well when we analyze word frequency such as spam detection or sentiment analysis. The model is extremely fast, making it ideal for large dataset. So to overcome the weakness of NMB, we use component line bias CNB. Unlike NMB, CNB is designed to handle imbalanced dataset better, adjusting the way probabilities are calculated. Improve recall, meaning it reduces the number of false negatives. This makes it ideal for application where identifying minority classes is crucial, such as fraud detection. So this is our step in our model. First, data processing. Second, feature extraction. Third, model training and selection. And the last one, hybrid approach.
So my name is Junlok and I will be talking about implementation details. In this project, we have used two modules, which is the MMB and CMB. For the implementation details of these two models, we have used the pre-process functions, which involve the removing unwanted elements such as punctuations, numbers, and short words while preserving the useful words and contractions. So these functions contain several key features, such as the data cleaning for the data frame, the white space and the punctuation, filtering and normalization, and lastly, the short word removal. The second function in these two models is the removing the stop words, which is filter out some common words from the text that do not contribute to the classifications. The third function is the tokenizing the sentence. So this function is the process of splitting a sentence into the words and also includes applying the pre-processed words such as cleaning and formatting. So the last one is the removing the metadata such as header and the extra text. So these functions remove the lines before the actual text. Okay, so the next slides represent the output of multinomial naive bias and the complement naive bias. So the left pictures represent accuracy for MNB, which is 64%, while the complement naive bias accuracy is 64, also same as the MNB, which is 64%. So both models overfit slightly. The training accuracy is higher than the test accuracy. So their generalization ability is similar.
I'm Lo Kuan Yew, and I will be presenting the another model, which is a long short-term model and global vector for word embedding, which is GLOVE. Due to the fact that MMB and CNB model has shown drastically overfitting issues, I am using another set of model, which is long short-term model and global vector of word embedding to test our dataset again. For this set of model, I'm using a 100 dimension GLOVE model to embed words in each sentences, in each text of each sentences, and using the LSTM model with bidirectional features to try and improve the test accuracy and training accuracy for our dataset and prevent any overfitting issues. For these results, unfortunately, there's still a bit of overfitting issues in there, but it still counts as acceptable. However, the accuracy dropped drastically than before, especially the training results when we are using MNB and CNB model. We realize that we need to focus on generalization more than just high accuracy. So eventually we choose this result as our final result instead. Here we can see that training accuracy is at 64%, while test accuracy is at 63%, which is acceptable. However, there's still some improvement that we can make in the future.
In the end, we program multiple models to classify sentences into different sentiment value moving beyond positive, neutral, and negative, and understand how different models affect the accuracy of a sentiment analysis dataset. By understanding the initial working, layers and accuracy result of NMB and CNB, we try improving it by executing a combined model of LSTM and GLOVE, embedding to output a much higher accuracy while understanding the difference between models. NMB and CNB are effective for text classification, while LSTM, a deep learning approach, captures long dependency in text. Additionally, GLOVE converts words into dense vector representation, which improve contextual understanding. So this is the end of our presentation. Thank you.